area. It is just a smaller part of the slope, which you can see dimensions here, and some adopted values of the geometry of the slope. Very short reminder about kinematic analysis, which were the first thing one of the first things that we do on our data on the point cloud. So this is basically the preliminary method of slope stability analysis, which is based only on the geometry, based only on the orientation of the discontinuities and the slope itself. And what we are looking for in the rock masses are planar, wedge, and toppling kinds of failures. So there are well-known conditions for which we can track to track down these failures. What is tricky is when the geometry is more complex, when there is local topography introduced, like in our case with the slope, which is faceted and rounded, so that we need several scanning points instead of only one, which is additional work and additional processing time. But in our pilot case study, we didn't have to do all this, so we had a simpler case in our pilot case study. So this first study is relatively simple. So as I mentioned earlier, we discovered three significant discontinuity systems. One is the Bedic system, which you can see here on the point cloud. We mapped it directly on the point cloud. The software allows direct plot on the stereo net. Those are all the points with all the strike and dip coordinates. Then we mapped another joint system, and the third joint system, which is practically perpendicular to the road, and this one is parallel to the road. After that, we performed the kinematic analysis, so we introduced to the stereo net the geometry of the slope. We added one case with friction angle of 20 degrees and another one with 30 degrees. In both cases, it is obvious that we have a planar failure potential for joint system 1 and also wedge failure possibility for joint system 1 and 2. So these are conclusions of our kinematic analysis. And now finally to the monitoring, which, as I mentioned, started in 2011 with limited resources, so that what you can find in the preceding paper is the comparison between 2013 and 2011. So in 2013 we finally got our equipment and we started working on the entire slope, but we can only compare the parts, the pilot part between 2013 and 2011. As you can see on this image here, there is not too much change happened between the two sequences. Basically, it's all zero, that there are no deformations, apart from the positive deformations here in yellow, which is probably vegetation which hasn't been filtered out entirely, and the blue ones, which are negative changes. So these are the parts where the rock mass is missing. And they are not so abundant throughout the scene. We were particularly interested in one part of the slope where we discovered that there was a bit higher chance of rockfall, and this is the detail of that small boulder with size of volume of 0.3 cubic meters that we calculated. So basically not a big deal. Yeah. In 2014, we performed another scan. So this is what you cannot find in the paper. These are new results. And regarding the pilot area, there is not too much change at all. But in other parts of the slope, which are outside the pilot area, we found a relatively large boulder of approximately 2 cubic meters, which has been detached from the mass. What we are planning for our further research is basically continuation of the kinematic analysis over the entire slope, and also some additional measurements and extraction of other important parameters throughout the rock slope. We have seen a lot of nice presentations and heard a lot of nice talks throughout this conference about semi-automated volume calculation, also surface roughness calculations, and this is what we would like to continue in research, and we will definitely follow our colleagues that have presented this conference regarding the surface roughness, regarding the semi-automated extraction of joint spacing, of joint density, and volume calculation. So in conclusion, the technology seems really perfect for kinematic analysis. It is also perfect for monitoring. We have discovered some rockfalls in the second sequence, some significant rockfalls in the second sequence, and also it gives a concurrent output which can be used together as a supplement to the original or conventional geological mapping. And as I already mentioned, the research has further perspective on this site and also on other sites that we are dealing with. So on behalf of our team, thank you for your attention.
Thank you, Milos, for